Hi guys, so I'm going to do an algorithm analysis questions with you. I'm using one example from the December 16, 2016 foundation exam. And we're going to be doing this one here, okay? So this is number 2 in part A. So let's read the problem statement. An image processing algorithm takes O of n cubed time to run to filter an n by n pixel picture. If it takes 8 seconds to process a 1024 by 1024 pixel picture, how long will it take to process a 1536 by 1536 pixel picture? Okay, so for these types of questions, it's just a matter of deciphering what the hell they want in the problem statement and translating it into a math equation. So you're given a runtime of n cubed, and it's saying that this is the runtime it takes for an n by n pixel picture. Okay? And that's great because the next sentence, it gives you an example of what is the actual time for an n by n pixel picture. In this case, our n is 1024, and the time it takes is 8 seconds to process. So again, we're given a runtime, an n for that runtime, and the time it takes for that n. Does this sound kind of cool? Because they just gave you a solved equation, essentially, okay? Now, the problem is asking how long will it take to process a 1536 by 1536 pixel picture. And I'm going to show you how to do this, okay? So for these types of questions, this is our equation here. Let t of n equals some constant times your runtime, where c is some constant. Now, if we can solve for this constant c, and we have n, then we can solve for a time for any arbitrary n in theory, right? Now, if you think about it, what is this c here? C is just some constant that is just chilling out with your runtime, but it's a constant that is exactly that. It's a constant. It stays the same for any arbitrary n. So this is why it's very important that if we can solve for c, then we can use it and utilize it to solve for any arbitrary n. All right, so let's rock and roll. Step 1, solve for c. So I have t of n, where n equals 1024, is equal to c times n cubed equals 8, because we're given that piece of information on our problem statement. And this is awesome because now we have right here, if I just maybe this will be clearer to see. Move that down a bit. That looks really weird. Hold on just a second. Okay, we'll just roll with this. As you can see, we have c on one side of our equation equal to a number. Therefore, we can solve for c. c equals 8 divided by 1024 cubed. Oops. Great. So now that we solve for c, we're going to use that c to solve for a time for arbitrary n. And our arbitrary n that we're interested in happens to be 1536. Step 2. All right, so let's go ahead and plug in n equals to 1536 equals c times 1536 cubed. Again, this is our runtime, and in this case, we're trying to solve for the time recall back, we were given the time for 10:24, but in this case, we're trying to solve for the time, and we can do that because now we already have C. So let's plug in C is there. And look, we just have numbers. So this will actually result in a number. We just have to simplify this. So for these types of problems, it's gonna simplify to a pretty nice number. That's usually the general case. So you want to try to find the greatest common factor. You will notice that 1536 here and 1024, the greatest common factor is 512. You're not given a calculator, but that is usually the case that big numbers will have a nice greatest common factor that simplifies the equation really nicely. So keep that in mind when solving these questions. Okay. And our 8 cancels out. And I was being really sloppy with my units, but there's a seconds is the only unit in this equation here. So 27 seconds is your final answer. Boom. Oh gosh. Okay, yeah, so 27 seconds. And let's double check. Yep, there we go, 27 seconds. Great, so I hope this video helped and good luck.